Hello everyone. In this video, we are going to discuss some problems on series and parallel circuits and DC circuits. Let us take the first problem where a direct current circuit comprises of two resistors, resistor A of value 25 ohm and resistor B of unknown value. These two resistors are connected in parallel. Let us start integrating these parameters and let us draw the circuit. We are having two resistors, resistor A and resistor B connected in parallel. Let us start connecting these two resistors, resistor A and resistor B. Resistor A is having 25 ohm resistance, and together with the third resistor C of value 5 ohm connected in series with the parallel group. With these two parallel groups, we are having one more resistor, resistor C, which is of 5 ohm. And now the value of resistor B is unknown. The potential difference across resistor C is found to be 90 volt, which means VC is equal to 90 volt. And the total power dissipated in the whole circuit is 4320 watt and 4320 watts. Which means the circuit needs to be completed with a voltage of applied voltage V with a power P is equal to 4320 watts, and the total current is unknown, right? And we need to calculate the value of resistor B is unknown, and the voltage applied to the whole circuit. We need to calculate V. Now these two are the unknown parameters that we need to identify. Let us solve this problem. Now we are having the circuit connected. To know the value of V, the total voltage applied across the circuit, there is a formula that we can use. V is equal to P by I. Since the value of P is known and the value of I is unknown, we can, if we calculate the value of I, we can use it to get the value of V. To know the value of I, since in a series circuit the current remains same, if we calculate the current flowing in resistor C, that would be same as that of the total current I. Now if we calculate IC, that would be easy to calculate I. Let us start with these known parameters here. For this resistance, VC is equal to IC into RC, that we can take V is equal to I into R formula. Since VC is known, that's 90 volt, and IC is unknown, let it be unknown. RC, the value of RC is 5. From this, IC is equal to 90 by 5, that we can take it as 18 amps. Since the value of IC is known in a series circuit, the current remains same throughout the circuit. That can also be equated for I. Since we got the value of I, we can calculate V. V, total voltage V applied is equal to total power divided by the total current. The value of P is equal to 4320 watts. 4320 divided by the value of current I is now 18 amps. This we can calculate. 4320 divided by 18, that's our 240. Now we got the total voltage applied across the circuit is 240, that we can write. In series circuit, the voltage divides. Since we know the value of voltage across resistor C, now we need to calculate the voltage across resistor AB. Since the resistors A and B are in parallel, the voltage will remain same. Okay. Now let us calculate the voltage applied across resistor B. If we take these two as series, total voltage applied V is equal to VAB That's the voltage across resistor AB, which remains same, plus the voltage across VC. Now the total voltage applied is 240, which is equal to VAB plus 90. From this we can take VAB is equal to 240 minus 90, that's 150 volt VAB. Now we got the total voltage applied across the resistor B, and if you calculate the current flowing through the resistor B, we can easily calculate the resistance. Since the total current I flowing through it is 18 amps, okay, the current flowing through the resistor A, VA is equal to IA into RA. Now VA is 150, in a parallel circuit voltage remains same, IA is unknown, let it be IA. RA is 25. Now with that, IA is equal to 150 divided by 25, that's 6 amps. Since the current flowing through the resistor A is 6 amps, from this we can tell the total current I is dividing among IA and IB, that's I is equal to IA plus IB. Now the total current is 18 amps, now IA is 6 amps and the IB is unknown. From this, IB is equal to 18 minus 6, that's our 12 amp current flowing through the resistor B. Now with this IB and the voltage VAB, we can calculate VB is equal to IB into RB. VB is same as VAB, since in parallel circuit voltage remains same. 150 is equal to IB is 12 and RB is unknown. Now RB is equal to 150 by 12. 150 divided by 12, that's 12.5 for us. Now the value of B is 12.5 ohms. Hope you people found it useful. If you have any doubts, please do comment below. Let us take the next problem. Moving on to the second problem. Find the current I1 and I2 in the given circuit, and here is our circuit. The total voltage applied is 10 volt. First one is 3 ohm parallel 2 ohm, and the other parallel circuit are 4 ohm and 4 ohm in series. Now the current flowing here is I1 and here it is I2. At this point, if you consider this current flowing here as I3, that would be the incoming current I1, the outgoing current I2. Here it would be I1 minus I2. Okay, just let us take the loop here, loop 1 and loop 2, and if you apply KVL for these two, for loop 1, if you apply KVL, 10 is equal to the current I1 is flowing 3 times I1 plus the direction of current is in direction of the loop, so I1 minus I2 into 2 ohms, that's 2 into I1 minus I2. And if we solve this, 10 is equal to 3I1 plus 2I1, that's 5I1 minus 2I2, marked as equation 1. And for loop 2, the current I1 minus I2 is flowing against the value, and there is no voltage source. We can take it as 0 is equal to minus of 2 times I1 minus I2 plus, since the direction of the loop is same as the direction of the current, 4 times I2 for this, and here again I2 into 4, that's 4 times I2. Now if we solve this, 0 is equal to minus 2I1 minus into minus is plus 2i2 plus 4i2 plus 4i2, that's our plus 10i2. You can mark it as equation number 2. And if we solve equation 1 and 2 simultaneously, that's our 5i1 minus 2i2 is equal to 10, and minus 2i1 plus 10i2 is equal to 0. If you solve these two simultaneously in a conventional method by multiplying equation 1 by minus 2 and equation 2 by 5, that's the coefficient of first equation I1, and this is the coefficient of second equation I1. Now if you multiply it, we will be getting minus 10I1 minus into minus plus 4I2, right, is equal to 10 to 20, that's minus 20 for us. And here 5 into 2 is minus 10I1 plus 5 into 10 is 50I2, which is equal to 0. And if we solve this simultaneously, plus, minus and 0, these two get cancelled, and here we will be getting minus 46I2 is equal to minus 20, or I2 is equal to minus 20 by minus 46. That's I2 is equal to 0.43 amps. Okay, minus get cancelled, here we'll be getting plus 0.43 amps. Now if I2 is equal to plus 43 amps in equation 1, from this equation we can calculate 10 is equal to 5 into I1 minus 2 into the value of I2 is 0.43, that would be 10 is equal to 5 into I1 minus 0.43 into 2 is 0.86, 0.86. 5I1 is equal to 10 plus 0.86, that's 10.86. I1 is equal to divided by 5, that's 2.17 amps. This is the value of I1 and I2, that's I2 is 0.43 amps, right? Hope this was helpful, and if people have any doubts, please do comment below. Thank you.